Day 771 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3838, weighted word mapping. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array of strings word where each string represents a word containing lowercase English letters. You are also given an integer array weights of length 26 where weights of I represents the weight of the ith lowercase English letter. The weight of a word is defined as the sum of the weights of its characters. For each word, take its weight modulo 26 and map the result to a lowercase English letter using reverse alphabetical order. So 0 maps to Z, 1 maps to Y, all the way up to A maps to 25. Return the string form by concatenating the mapped characters for all words in order. Alright, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, first thing I'm going to do is let's just bring this over. I'm going to copy and paste this over here so we can see how the characters map, because for this right here, you can see 0 maps to Z, boom, 1 maps to Y, boom, all the way up to 25 maps to A, boom. So we have a visual representation to look at. So now let's look at the example. So in example 1, our input words equals an array of strings A, B, C, D, next string D, E, F, last string X, Y, Z. Weights equals an array of integers 5, 3, 12, 14, 1, 2, 3, 2, 10, 6, 6, 9, 7, 8, 7, 10, 8, 9, 6, 9, 9, 8, 3, 7, 7, 2. Boom. And our output is the string Rij. So let's see how we got this output from this input. So the explanation says the weight of A, B, C, D is 5, 3, 12, 14. So first thing we want to understand is there are 26 numbers here, and each one of these 26 numbers maps to a character in the alphabet, right? So 5 would be for A, this would be B, C, all the way up to this 2, which would be Z, right? So for A, B, C, D, that means we're looking at the first 4 elements or numbers in this array, which would be 5, 3, 12. When we add 5 plus 3 plus 12 plus 14, and 14, that equals 34. Then we take the sum and we, for each word, take its weight modulo 26. So we take the sum and we mod it by 26. So 34, 26, mod 26 equals 8. Boom. And then we come over here, we find 8, make 8 maps to R. So boom, that's where this first R comes from. Then we're doing this string, DEF. DEF maps to 14, 1, and 2. When we add 14 plus 1 plus 2, that gives us 17. 17 mod 26 equals 17, which maps to I. So we come over here, 17, that maps to I. Boom, that's where this I comes from. Then we get XYZ, right? We have XYZ, that's this 772 right here. Boom, so 7 plus 2 equals 16. 16 mod 26 equals 16. So 16 maps to J, right? Boom, maps to J. Boom, that's where this J comes from. So that's how we got this output, Rij, just like that. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, our input words equals a string, first string A, second string B, last string C, weights equals an array of integers of ones. It's all ones with the count of 26. It's 26 ones right here. Boom. The output is Y, Y, Y. Why is it Y, you ask? Well, let's look at the explanation. It says each word has a weight of 1. So the modulo 26, 1, or excuse me, 1 mod 26 is equal to 1, which maps to Y. Thus, the string is formed by concatenating the map characters as Y, Y, Y. So all of these, as you can sense, every element in this array is 1. That means all of these strings has a weight of 1. When we take that weight of 1 and mod it by 26, we get 1 for each one of these. So we take this 1 mod 26, we get 1, 1 maps to y. Boom. So right here, boom. So we put our first y. Same thing right here. This maps to 1 right here, 126. That's gonna be 1 mod 26 equals 1. Over here, maps to y, we put another y. Boom. Then this c right here maps to this one right here. Once again, 1 mod 26 equals 1. This one over here maps to y, so we put a y. And in the final output, we get y, 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 and that's how we got it. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our input words equals an array of strings A, B, C, D. Weights equals an array of integers 7, 5, 3, 4, 3, 5, 4, 9, 4, 2, 2, 7, 10, 2, 5, 10, 6, 1, 2, 2, 4, 1, 3, 4, 4, 5. This time the output is G. Boom. So we only have one string up here. So once again, that's going to be 7, 5, 3, and 4. Boom, when we add them all together, we get 19. When we mod 19, 19 mod 26 equals 19. We come over here to 19. 19 maps to G. So we put a G right here for our output, and that's how we got it, y'all. So boom, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution is not that difficult at all. Now, first thing we want to do is we need to create a variable to store the final output string that will be built one character at a time for each word. So we'll just declare variable called result, and we'll set that equal to a blank string. Boom. Then we need to process each word independently. So we're going to say for word in words. We're going to open up the bracket and we're going to convert the word into an array of characters so we can iterate through each letter. So we're going to say let R equal an array, open up the parentheses, word. Boom. Then we're going to come underneath that and we need to store the running total of the weights for each current word. So we'll just declare a variable called sum and we'll set that equal to 0 to start. Now we need to add the weight of every character in word. So we're going to say for C in R. We'll open up the brackets and we're going to convert the character to its ASCII value. So we're just going to say sum plus equals weights square bracket and open up the parentheses C.ASCII value. Sorry, I said value, exclamation point, come outside of that, and we'll say minus 97. Boom. Now we need to reduce the total weight into the range of 0 to 25. So we'll come underneath this, and we'll say let M equals sum mod 26. Boom. And then we need to convert the value into a new lowercase letter. So where 0 maps to Z and 1 maps to Y, all the way up to 25 maps to A. So we're going to say, come underneath this, and we're going to say, let ASCII value equal 25 minus M plus 97. Boom. Boom. Now we need to create a Unicode scalar form from the ASCII value. So we come underneath this and we say if let scalar equals Unicode scalar, open up the parentheses, int, open up the parentheses, ASCII value. Then we'll come outside of that, we'll open up the brackets, and we're going to convert the scalar into a string by saying let string equal string parentheses scalar. Then we'll come underneath that and append the generated character to the result. By coming underneath that, we'll say result plus equals string. Boom. Then we need to return the final string containing one generated character for each input word by coming underneath this. And we say return result, y'all. Boom. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, it's going okay. I was about to say it's going a little slow. Oh, this should be plus 97. Sorry, y'all. Now let's run it. See if that makes it run faster and get accepted. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Oh, look at that, y'all. 11 milliseconds beats 11.11% of users. Not too bad. Not too bad at all, y'all. So with that being said, make sure you get one more look at the code. This is the top part. And this is the rest of it. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.